All right, we can also think about negative powers as representing the reciprocal factor. So we know that the reciprocal of 3 is 1/3, and we also know that 3 to the negative 1 power is 1/3. So what happens then if we have a factor? What if we have a fraction like 1/3 to the negative 1? So is it the same as the reciprocal? So the first thing we're going to do is apply that power of negative 1, and that basically tells me to take whatever's the factor is and write it 1 over that factor. So that doesn't look very nice, but we know that this is just division, so this is the same as 1 divided by 1/3. And now we know how to handle division of fractions. We invert and multiply. So this is the same, and we take our factor here, and this would be the same as 1 times then 3 over 1, which is just equal to 3. So it looks like we got 1/3 to the negative 1 is the same as 3, which is the reciprocal. So would it work with a fraction like 3/5? You know, should we get 5/3? And again, if we just rewrote this, applying the negative exponent would be 1 over that factor of 3/5. And of course, this is the same as 1 divided by 3/5. Invert and multiply. This is the same as 1 times the reciprocal 5/3. So it looks like this is equal to 5 over 3, 1 times 5/3. So therefore, we got that 3/5 to the negative 1 power is the same as 5/3. So in general, if I have like a factor of x over y, a fraction, and all of that's raised to the negative 1 power, then that's the same as just taking the reciprocal of the fraction. Now, how can we use this and generalize more? So that is one nice thing about negative exponents. They represent reciprocals. So let's look at this last one. What if then, instead of applying the negative 1 power, how about if we use, if we notice this is an outside power. So if we apply the outside power to every factor, we would have 3 to the negative 1 over 5 to the negative 1. Now, if we rewrote this, this would be a complex fraction. 3 to the negative 1 would be the same as 1 over 3. And 5 to the negative 1 in the denominator is the same as 1 over 5. So this, again, is a division problem. This would be the same as 1/3 divided by, 1/5. If we invert and multiply our divided fraction, we would get 1/3 times 5 over 1, which is the same as just 5 over 3. So what I want to look at then is we had 3 to the negative 1 over 5 to the negative 1, and that's equal to 5/3. So in a sense, what's happening is the negative exponent on factors basically just converts or changes the position of the factors in the fraction. So if we notice the 3 to the negative 1 was a factor in the numerator, that just moved to a factor of 3 in the denominator. And 5 to the negative 1 in the denominator moved to the numerator as just 5. So I like to think of this then, if we have a fraction where we have a factor x to a negative 1 power in the numerator, and maybe a factor y to the negative 1 power in the denominator, this is equal to, well, the x to the negative 1 moves that factor of x to the denominator, and the factor of y to the negative 1 moves to the numerator. So these negative exponents are basically changing the factors between fractional, or factors in the numerator and factors in the denominator. So one of the things when we see these and we want to start simplifying with them is that when we have a negative exponent, when we have a negative exponent, we want to basically change the position of that factor in the fraction first. So when I look at this, I have a fraction, this is a, I have this x to the negative 3 in the denominator. So I know if I convert that to x to the negative 3 in the denominator would move to x to the third in the numerator. X squared is a positive factor, that just stays in the numerator. So we had a fraction to start with, but since one of the factors is negative, it changes position. There's actually no canceling that happens here because the x to the negative 3 moved up to the numerator. This actually then, if we multiply those common bases, we get x to the 5th power. So we don't want to start canceling until our exponents are positive, our factors are in the correct positions. So again, when we look at a fractional expression like b, I want to identify the factors that are to negative powers. So here's x to the negative 2, and then we have a y to the negative 5 in the denominator. So I'm just going to rewrite these factors. 3, if we look at the factor of 3, that stays in the numerator, there's no negative power. X to the negative 2 is going to move to the denominator as x squared. Y to the negative 5 in the denominator moves up to the top as y to the 5th. This factor of y to the 4th in the numerator stays in the numerator because it's a positive exponent. 2, the factor in the denominator, stays in the denominator, and x to the 4th also stays in the denominator. It's a positive exponent. So now all of my factors are positive exponents, so I can multiply these common bases. This then would just be equal to 3. Y to the 5th times y to the 4th is y to the 9th, just adding exponents, over 2. X squared and x to the 4th would be x to the 6th, just adding those. So again, we want to convert all negative powered exponents. We want to rewrite those in the fraction in the right position. So let's try this one. Let's rewrite each of the negative factors. So here's negative powered factors, excuse me. So 5 to the negative 2 is going to move to the denominator as 5 squared. A to the negative 9 is a factor and moves to the denominator as a to the 9th. A to the 14th is a factor that stays in the numerator. It's a positive exponent. 3 to the negative 3 in the denominator moves to the numerator as 3 cubed. B to the 4th is a positive exponent, so that stays in the denominator. And then b to the negative 8 would move to the numerator as b to the 8th. So now all of my factors have positive exponents, and I can use canceling to multiply them. So I'm just going to use canceling and then simplifying. So first of all, we'll start 3 to the 3rd power is 27. So we have a to the 4th over a to the 9th. So if we cancel the 9 a's in the denominator with 9 of them here, we'll have a to the 5th in the numerator. B to the 8th over b to the 4th, so all 4 of the b's in the denominator will cancel, leaving 4 b's in the numerator. So this would be b to the fourth. And then the last one, we have this factor of 5 squared in the denominator that stays there. 5 squared is 25. So again, it's really important that we cancel positive powered factors only. So we want to convert all the negative powered factors to positive, basically before we cancel.